Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Echoing Cages by Graggle. And here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this case. We have killer cages, where digits in cages must sum to the number in the top left corner and cannot repeat digits. Or cannot repeat, I guess. Digits in cages cannot repeat. Okay, that makes sense. So, for example, these 7 digits must add up to 38. These 7 digits must add up to 29. These 7 digits must add up to 35, etc., etc. And you cannot have a repeat in the cage. So take that with some interesting information. And there's a lot of them. So for example, if you had a 2 here, this would have to be 7 because these 2 digits must add up to 9. That's an example of how killer cages work. We also have zipper lines, where digits in equal distance from the center of a lavender line must sum to the digit in the middle of that line, right? So for example, this could be a 9 here, and if this were then a 4, this would have to be a 5, because digits that are an equal distance away from the center of the zipper line must add up to the sum, that the digit that's in the middle. So for example, if this were 4, this would then be 5, because these 2 digits, again, must add up to 9. These 2 digits must add up to 9. So say we had a 1 here, this would then be 8. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we have a cage, we have a box here, which is filled with cages. So this is 32, this is 10. That means the total of these are 42. 45, which is the sum of the digits 1 through 9, which you have to have in a box, is 45 minus 42 means this has to be 3. That means that's 3 in the corner. We celebrate. I don't know why, but we're celebrating because we got our first digit, I guess. That means these 3 digits must add up to, must be either 127 or 145. Either way, it requires a 1. Therefore, we know 6, 8, and 9 have to be here, and it's with 2 and 7 or 4 and 5 here. Also, on these cages, since there are no repeats, we know there are 2 digits which are not in this cage, and they must add up to 45 minus the sum of these cages, and that's for all of these cages here, right? So, for example, the sum of these 7 digits are 28. That means there's 2 specific digits that are not there, and if you have 45 minus 28, that gives you 17. So those 2 specific digits must add up to 17. So there must be 8 and 9 that are not in the cage. So this is 1 through 7. Similarly here, this cage, it adds up to 29, so the 2 digits not in the cage have to add up to 45 minus 29, which is 16, which is 7 and 9. So these are specifically 1, 2, 3, 4, 5, 6, and 8 in this cage. For this 35 cage, we have 2 digits which add up to 10. So it could be, so we know there's a 5 in one of these cages. This has 3 unique digits at least, less than it. So this is at least 4 here. We don't know if it's any greater or any less. This has 2 unique digits less than it. But, so the sum of all these digits, the digits that are not in this cage, sum to 7. So the 2 digits not in this cage have to be in these 4 digits, 4 cells here. In addition, you have to have the 2 digits that are outside in this 4-cell cage, right? So what if we had this as 3 and 1 and 2? Is that possible? The two digits not in this cage add up to 7, right? 45 minus 38 is 7. Actually, this can never be 3, 1, and 2. Because the two digits outside this cage, or not in this cage, have to add up to 5. 45 minus 40. And that would be either 1, 4 or 2, 3. So you cannot have both 1 and 2 in this cage. So therefore, this can't be 3 added up together. You can't have both 4 with... You can't have 4 with 1 or 3 in this cage. So this can't be 4 either. So there can't be 3 adding up with 1 and 2 because you can't have 1 and 2 in this cage at the same time. You can't have 4 with 1 or 3 because that would be 3 and 1 in the same cage or 3 and 4 in the same cage, and that's not allowed to add up to 40. You could have 5. So this is 5, 6, 7, 8, or 9. So the 5 would either be with 1 or 4. Or 2 and 3, and that's allowed in both. 6, you could have 1, 5 together. You could not have 2, 4 together, though. This adds up to 39. So in all these cages, there are 3 digits. So these 3 digits, these 7 digits must add up to 38, which means that you have to have the digits outside are either 1, 6, 2, 5, or 3, 4. Which means 7, 8, and 9 has to be in this cage. For the 40 cage, you have to have 2 digits adding up to 5, which is 1, 4, and 2, and 3. So 5, 6, 7, 8, 9 are in this cage. We know that for certain. And in this cage, the 2 digits outside have to add up to 45 minus 39, which is 6. So that leaves 1, 5, and 2, and 4 not in this cage. So in this cage, we have to have 7, 8, and 9. In this cage, we have to have 5, 6, 7, 8, 9. And in this cage, we have to have 3, 6, 7, 8, 9. Well, all of them must have 7, 8, or 9 in them. 3 cannot be here, and 3 cannot be here because of this 3. That means in 3 boxes, we have to have the 7, 8, 9 be in the cage. So this cannot be 7, 8, 9. It has to be 1 through 6. This is not 7, 8, 9. It's 1 through 6. 3 cannot be here. 3 cannot be here. Okay. What does that mean? I'm not sure. Okay, well, we do have a sum total for all of these digits, right? And we know 3 times the 3 sets of 9, 3 sets of 1 through 9 must add up to 135 because it's 45 times 3. So we have 135 for all 3 boxes. And for the cages, what are the cages? So we can remove the outer cages here because it's not too helpful. The sum of this is 39 times 3, right? Because 1 is 38, 1 is 40, which is 1 less and 1 more than 39 times 3. 39 times 3 is 117 because it's 40 times 3, which is 120, subtracting 3. So 117. So we have 135 minus 117 135 minus 117, which gives us 18, right? 135 minus 117 is 18. We don't have any other restrictions, though. Hmm. uh, what about these, actually? Um, the sum of all of these or these three specifically, these three cages, is 35 plus 29 plus 28. Oh, so we need a 9 here, right? In this box, where's the 9 going to be? It can only be here. So this has to have a 9 in it, which means this is 1 and 9 at least. So you have 1 and 9 in this cage. Because actually that's not true. No, that is true. You have 2 digits which must add up to 10. If you had a 1 outside, it would only be with 9 outside the cage. So 1 has to be in the cage. Which means we have to have a 1 here, we have to have a 1 here, we have to have a 1 here. Maybe we can restrict it even more, though, by the sum. So the sum is 29 plus 28, which is 57. 57 plus 35. 57 plus 35 is 92. Right? Yeah, 92. So 135 minus 92 is 43. 43 minus 24, which is the most 3 unique digits can be. Oh, so this is 9 here, which means 9 does have to be one of these digits here, and 9 has to be one of those digits there. Okay. You could have 24 in one set of these 4 digits. So 43 minus 24 is 19, which means this has to be 2 through 9. So that doesn't restrict it to any more than we had, unfortunately. 2 could be on this zipper line, we don't know. Hmm. So again, these two sets of pairs of 3 cells of digits, these pairs of 3 cell digits must add up to 18 here. These pair of 3 cell digits must add up to 43. That's not that restrictive, unfortunately. Oh, that's interesting. Where is the 9 in row 4 and column 9? 9 has to be here, so it cannot be in this cage. There cannot be a 9 in this cage. There cannot be a 9 in this cage. There cannot be a 9 here. There can't be a 9 here. So therefore, along row 4, the 9 has to be one of these 4 digits. Along column 4, the 9 has to be one of these 4 digits, but it can't be along both of them, right? Unless it's in this cell. If it were here, if it were any of these three cells, that would eliminate a 9 possibility for any of these cages. So therefore, this must be a 9 here. Because that's the only place for it. That can be in row 4 and in column 4, right? Because it can't be here, can't be here, can't be any of these two. It must be in the cage. If it's in one part of the cage, it can't be in the rest of it. And both column 4 and row 4 have to have a 9. So this is 9, which means this can never be 2. It's 1, 8. This can't be 1 here. So 1 has to be here, which means 1 cannot be here or here. This is 2 and 7, 3, 6, or 4, 5, adding up to 9. This can't be 9 here. This cannot have a 5 here, right? Because it could be 5. Never mind. So this is 1 through 8. 1 through 8. Huh. So that's the only digit we know for certain has to be there. These digits are 1 through 7 to add up to at most 8. Hmm. What else do we have? These 2 digits must be in one of these 4 digits here. Oh, interesting. So we need a 7 and 8 in this cage, right? If the 8 is here, it cannot be here. So therefore, there would be a corresponding 8 in this direction, right? So if there's an 8 going this way, you need a corresponding 8 going in one of these 2 cells, which would force 1 to be one of those 2 cells. So 1 could not be here or here. That doesn't tell us much. We have a 7 in the similar situation, right? So if you have a 7 here, that eliminates 7 here, but it also eliminates 7 in this column. So 7 would have to be here, which meant 2 would have to be here. But does that tell us anything? I'm not really sure. Where can 1 be in row 7? 1 has to be one of these 4 cells, right? Hmm. Hmm. What digits? Hmm. So 9 has to be one of these 5. 9 has to be one of those 5. Hmm. Mm. These 2 digits must be in these 4 digits. We also have a 9 here. What is the last remaining digit? Hmm. Oh, this adds up to 9 for these 2 digits. So therefore, this is what? These add up to 9, these add up to 9, and these add up to 9. What does that leave here is the question, right? So again, it's what, 92? I think it was. 35, 29 plus 28 is 57. 57 plus 35 is 92. 92 minus 3 times 9. Okay, 92 minus 45 is 47. Right? So we have 47 in these 6 cells and 47 in these 6 cells. 47 minus 9 times 3 is 27. That leaves 20 in these 3 cells and 20 combined in these 6 cells. But does that tell us anything? I'm not sure. Hmm. I don't think it does, right? We just know it can't have a 9, but the other one be up to 6, right? Which gives us 14 max for the other one, which could give us 8. Hmm. If 8 is in one of these cells, again, it forces 8 not to be here, so or here, so 8 has to be here correspondingly. Hmm. Hmm. Uh, so this is here. Ah, these two digits add up to 9. Therefore, these 5 digits must add up to 28 minus 9, which is 17. No, 19. Oh, it's 19. Oof. I thought it was more restrictive. No, 19 is much higher, so it doesn't restrict as much. I think a 1 does have to be, yeah, 1 has to be there, but 2 does not. 45 minus 19 is 26, so it's 2 through 9. Um, hmm. Um, huh. We know 1 has to be one of these. Hmm. These 3 digits obviously are not in any of these 6. Um, they're not guaranteed to not be in any of these 3. We know one of 8 and 7 is here or here, and then the other of 8 or like, yeah. You could still, it could be 7 and 8 here, right? Which would force this to have 7 and 8. Hmm. Oh, that's interesting. So, if this were, say, a 7, 8, 9 here, the problem is that would force 7 and 8 not to be here. So 7 and 8 would have to be here. So it can never be 2, 8, and 9 here or 3, 7, 9 added up with the 7, 8, 9 to add up to 43. right? So I think this has to be 4 through 9 here. It's not quite as cut and dried as this, but yeah, since 7, 8, and 9 could be here, so if it was here, say 7, 8, 9 was here, that meant 7, 8, 9 cannot be here. Both 7 and 8 have to be here, which means 7 and 8 cannot be here. So 7 and 8 would have to be along this zipper line. So this could never be 289 or 379 or 389 added with this 24. So I think this has to be 4 through 9 here, and this has to be 4 through 9 here. Because we are restricted by the 7 and 8 having to be in row 4 and column 4. Right? So you can't have both 7 and 8 not be. So you can't have like 8, 9 here and 8, 9 here. Right? If you had 8, 9 here and 8, 9 here, neither of these could be 8 or 9, and then therefore the 8 would not be in either row 4 or column 4, because there's only one 8 possible in this cage. And none of these could be 8 because of the restrictions, because we know 7, 8, and 9 have to appear in the cages. So yeah, I think this has to be 4 through 9, right? If we try to make it 2, if we try to make it 2, 8, 9, or 3, 8, 9, the problem is that would require an 8 and 9 on the other side, which is not possible. So this is 4 through 9 here. This is 4 through 9. You could have 4, 6, 9, though. And that works. What does that tell us? I'm not sure. Is it similar with ones? I don't think so. Like ones in this area. I don't believe so. Because you could have 2, 3, 4 on both sides, all right? 4, 2, 3, 4, 2, 3. Um, yeah. Hmm. Oh, that's interesting. Hmm. What happens if these are the same digits is kind of interesting. This 19 cage, that's actually interesting too. This 19 cage either has a 9 in it. If it doesn't have a 9, I guess it could be 4, 7, 8 or 5, 6, 8. Okay, not as interesting. Hmm. Okay, never mind. I don't think that restriction is as important. What else do we have? Hmm. One thing you cannot have is, for example, you're missing 1 5 here, 1 4 here, and 1 6 here, right? Because obviously there has to be a 1 in these cages somewhere. But you don't have to have two ones. You only need one one, right? Same with all the twos, the fours, and the fives, right? So if there's a three, okay. If there's a three here and a three here, that means three cannot be here and three cannot be here because three has to be in this set. So therefore, this is missing three here, which would mean it's eliminating 2, 3 in this cage. And you don't have 3, 4 in this cage. So this would be 3. This would not have 2 or 3 here. Therefore, 2 would have to be one of these. This would be 3, obviously, and this would be 3. So you could not have 3 and 6 this way, or this way, because they add up to 9. 2 has to be one of these. Um, okay, that's interesting. So if that's the case, we know 7 has to be one of these two, and 7 has to be, or 7 has to be one of these two, right? With 7 being here and here only. So if this is 7, that would force this to be 2, so this couldn't be 2 anymore, and this couldn't be 2, so you could not have a 2 here or a 2 here. One of these would be 2 with 7, the other would be 2 with 7, right? Uh, Obviously 2 couldn't be here. 2 couldn't be any of these. 2 couldn't be any of these. You could have a 2 here and a 2 here. That could be possible. This has to contain a 4. So it's 1, 4. It has to be 1 and 4 here, if that's the case. Right, because 3 and 4 cannot be here, if that's the case. Whereas the 4 in this box, it has to be here. And the only ones that add up to another digit is 1 and 4, because you can't have 2 or 3 in there. So this would be 5 here. This would be a 1, 4 pair. This would be 2, 6, 2, 6, 7, 8. This would have to be 6, 7, 8, 9, 6, 7, 8, 9 here. That would leave this as a 1, 5 pair here. Okay. This would be 3 and 3. So that's 6. We have 18 minus 6, so both of these must add up to 12. You cannot have 1, 5 adding up to 12. It could be 2, 5 here and 1, 4 here, I guess. So this could no longer be 6 here. Yeah, it could be... you could add up to 6. No, sorry. Yeah, you could add up to 6 still. Right? You could have something like 1, 6 on one side, and then 2, 1, 4 on the other side. Oh, that's not possible. Because one of these is 1 or 5, and one of these is 1 or 5, right? So say you did have a 1, 6 on one side. If you had a 1, 6 on one side, the other side adds up to 5. Can't be 2, 3, it must be 1, 4. But then 1 would be on this side, and 1 would be on this side. I guess you could have 2, 2, 6, maybe? 2, 6, and then they would add up to 4. No, that's not possible. 3, 6, 3 to 6 doesn't add up, because we already have a 3 in that case. So I think it would have to be 2, 4, and 2, 4 on each side, because it can't be 1 and 5 adding up. We tried to have 1, 6. That doesn't work, because that requires 1, 4 on the other side, and one of these is a 1. So I think this kind of works. Okay, yeah, you can't have 1, 6. You can't have... You can't have 2, 6, because 2, 6 adds up to 8. The other ones would have to add up to 4, which is 1 and 3, but we already have a 3 in that box. And then 3, 6 obviously doesn't work because you would have to have repeat the 3. 4, 6 wouldn't work because that would mean 2 digits add up to 2. 2 unique digits add up to 2, which is never possible in normal Sudoku. So this would have to then be 2 and 4, I think. And 2 and 4. Which eliminates 4 and 5 here. And eliminates 4 and 5 here. Ah, but then we have a contradiction. Okay. Right, because 6 would have to be here, and then 6 would have to be here, but then you'd have a problem with the 6s, essentially, adding, not being here. And... Right. Okay. So that just shows us that we can't have 3... We can't have 3 being here and here, essentially, is the question, right? Which eliminates 3 and 4. What happens if you have any other... Could you have 2 unique digits there? I don't think so, right? So say you had a unique digit here and the same unique digit here. I guess it could be in one of these. You can't have... No, you could have 1, 2, 6 both ways here. I guess the question is, can you have 3 unique digits, the same 3 unique digits here and here? And I think the answer to that is no. Well, they would both add up to 9, right? I don't know if this is the way to go about it. Ugh. Um, hmm. Hmm. Okay, we know. Well, you can't have 1, 2, 6 twice here. We know that for certain. Because this requires a 6 and this requires a 6. So there's 2 sixes at least here. The same is not true for 5s, though. Basically, okay, so the 6 digits, which are not in these cages, must be the same as these 3 digits here, right? Because we have 9 digits all in these 3 boxes. So it's the same for this, right? That's why, yeah, you had 7, 8, and 9. So 8 and 9 is, there's an 8 and 9 missing here, a 7, 9 missing here. So that's why this has to be 9 and 9 here. One of these then is a 7, and then the other one has to have an 8, or both have to be 7 and 8 here in the same box. But if that's the case, then it's 4, 6, and 9. Right? Bingo. Okay. So, one of these sets does have to have a 7 and an 8, right? Oh, okay, okay. Yeah, yeah. One of these sets has to contain a 7 or 8. But in row 4 and column 8, because these can't be 7 or 8, these can't be 7 or 8, there's only one 7 or 8 in this cage. One of these has to contain a 7 or 8. So there must be a 7 or 8 in the other cage. Which means this, in one of these boxes, 7 and 8 has to be in a cage. Well, we already know 7 or 8 is in a cage in this box, so that means 2 7 and 8s have to be in the cages. Well, we have an 8 here. We have a 7. We have a 7 here, but this cannot contain 7 and this cannot contain 8. Because of that, where are the 7 extra 7 and 8 in the cages have to be? They have to be in this cage. And since they have to be in this cage, that means 2 8 and 3 7 cannot be excluded from that cage. Therefore, this has to be excluding 4 and 6. So this has to be... I hope that made sense. I'm not sure if it did. Because the excluded digits in these 3 boxes have to be in these sets, right? We know there's an excluded 8, 9. There's an excluded 7, 9 from this cage, and this cage, right? Because of what the sums of those cages are, right? So 8 and 9's missing here, and it has to be in one of these set of 6. 7, 9's missing here, and it has to be in this set of 6. This obviously has to have a 9, then, because that's the only cage that has a 9 available left. But because of the way row 4 works with the cage, there can only be one 7 or 8 along either row 4 or column 4. And since these can't be 7 or 8 because of what these sums add up to, right? There has to be a 7, 8, or 9 in all of these cages, no matter what. Therefore, these can't be 7, 8, or 9. That's how we got 9 here. We also know 7 and 8 have to be, one of them has to be here, and the other one has to be here, or both of them are in the same line. We don't know. But we can only account for one of the 7 or 8s in row 4 or column 4. And therefore, the other one has to be here, and the other one has to be here. Well, since 7 or 8 has to also appear in the cage here, that means we need 2 cages each with 7 and 8. Well, this only has 1. This can't have a 7. This can't have 8, so this must contain 7 and 8 from that. And therefore, since it requires 7 and 8, the 2 digits that it can't have cannot be 1, 9, because we need the 9 here. Can't be 2, 8, because we need an 8, 7, and 8 in this cage. Can't be 3, 7, because it needs a 7 in the cage. So it cannot have 4 and 6. Therefore, this is 1, 2, 3, 5, 7, 8. This is 1, 2, 3, 5, 7, 8, 9. So 4 and 6 cannot be here, which means these cannot add up to 3, 6, or 4, 5. So 3, 5 cannot be here. 3, 5 cannot be here. So this can't be 5. Okay, so this we can remove all the 5s along it. We can remove the 1s because now we know exactly what digits have to be there. So what are we missing then? We need a 4 and a 6. So we have 5 in all of these. We have 5 in all of these. 5 cannot be here. 5 cannot be here. We are missing a 4, 6, 7, 8, and a 9. This cannot be 3, 6, and 3, 6. It's either 1, 8 or 2, 7 here. What else does that mean? I'm not sure. Yeah, I don't know if that tells us anything else about the puzzle. Hmm. 4 and 6 could be here. If 4 and 1 of... Okay, that's interesting. So if both 4 and 6 are here, that means these two digits adding up would have to be 2 and 7. So we know one of these is 2, one of these is 7. So that would eliminate 7 from the rest of both of these. So it would be force these to be 1, 8, right? That seems kosher. One cannot be here. Okay, so that's one thing. That's why we had the ones being here and here. Okay, let's put those back then. These 4 digits add up to 26 again. If this is 4, that means 4 could not be here. So 4 would have to be on the outside. So it would be 4 and 5 on the outside. So if this is 4, it would have to be with 5, 8, and 9? Is that right? 5, 8, and 9 adds up to 22. Yeah. So 4 and 5 would be on the outside. This would be 5, 8, and 9, which would force this to be 2, 7, 2, 7, 1, 3, 1, 3. That works. Oh, wait. Yeah, you could have an 8 here. You would have 1, 8 here. Okay. Yeah, that seems fine-ish. Not great, but fine-ish. If you have 6 here, you can't have 6 here, so this would be a 3, 6 pair. You'd have the same problem then, right? It'd be 6 here, this would be 3, 8, and 9. Right. So this always has 8 and 9 here, right? Again, so this is 28 minus 9 is 19. 45 minus 19 is 26. This always has 8 and 9. Oh, that's interesting. So it always has 8 and 9. That's 17. 26 minus 17 is always 9, right? So 2 and 7, 3 and 6. So this can never be 3 here. Because if it were 3, it would have to be with 6 to add up with 8 and 9 to add up to 26. But 6 can never be here. Similarly, this can't be 5. Because if this were 5, that would force this to be 4 with the 8 and 9 to add up to 26. But there's no possibility for 4 and 6 to be here. Okay? Hmm. 2, 4, or 6 could be here. Oh, that's interesting. Okay. If this were 8, this could not be 1, 8. So one of these would have to be 1 or 8, right? So I don't think this can ever be 8 here. 8 is either in one of the excluded cells, which means it can't be any of these, or 8 is one along row 4 or column 4, which means it's one of these two. So I don't think 8 can ever be any of these or these, right? If it's either excluded, in which case 8 can't be in one of these cells, or it has to be in column 4 or row 4, which means then it still couldn't be in one of those cells. So 8 can never be here. Same with 7. 7 has to either be in the excluded cells or it's in on row 4 or column 4. So this can't be 7. This can't be 7. What does that? I don't know if that tells us anything. Never mind. 7 has to be one of these two or one of these two. 3. 7 is one of those two or one of those 3. 8 is one of those two here or one of these 3. 8 has to be one of these two here or one of these 3. Huh. Okay. What does that tell us? I don't know. Um, what about the cages here? We can only have 1 6 in one of these excluded cells. We could have as many as 2 1s excluded, 2 2s excluded, 1 3 excluded? No, 2. No, you can't have 2 3s excluded. Only 1 3 is possible to be excluded here. Because if we try to have 2 3s excluded, which means the 3 has to be here. 3 could not be, yeah. If you try to have 2 3s excluded, that means this is 3 and this is 3, which forces the 3 here. 3 cannot be here. This would have to be 1 4. 4 cannot be in any of these cells. So 3 would have to be here. 4 would have to be one of these two. This would be 5, 1 4. But then that would require 2 6 7 8, 2 6 7 8. The 3 would have to both be here, which eliminates 3 and 6 here and here. So the 6 could no longer be here from that. So that's the reason why we know we only at most 1 3 is excluded. Oh, that's interesting. Because only at most 1 3 is excluded, when they could have 2 4. You could have 2 1s excluded. One 6 1 5 and 2 3 works. 1 5 1 4 and 3 4. 1 5 1 4 could be 2 5, I guess, technically. Oh, that's interesting. Mm. Hmm. 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 Yeah. This was pretty cool to see how this interacted and to see what was missing. I'm trying to figure out if there's a way that we can figure out this. What digits are missing here? But I'm not seeing it, right? You have to have, you can't exclude one three times. You can't exclude two three times. You can't exclude three twice. You can only exclude it once at most. Four, you can exclude it twice at most. Five, you can exclude it twice at most. Six, you could exclude it twice at most. The only reason why three is limiting is the way that this three interacts with the rest of this of row four and column four. So you could have some you oh six no six you cannot have you can only have at most one missing and it would be 1 6, right? But you could have 1 6 with 1 5 and then 2 4. No, 1 6 with 1 5 or 2 3. 1 6 also works with 2 4 2 3 or 2 4 1 4. Oh, that's interesting. If you have a digit excluded twice, that means they have to be, one of them has to be here, the other one has to be here, obviously. It doesn't have to be in that cell here, right? It could be excluded here and then here. And it could be one of these cells. 6 and 3 cannot be excluded twice. All the other digits can't be excluded 3 times from 1 through 5, besides 3. So 1, 2, 4, 5 could be excluded twice. 3 and 6 can only be excluded once. Can you ever have the same exclusion, though? Maybe? What does it mean? Okay, so say you excluded 1 and 6 here. That means 6 has to be one of these excluded here. Hmm. Huh. That seems fine. Hmm. 7 does have to be one of those 5. 7 has to be one of those 5. Okay, what are the possible combinations that we can be missing here, right? We have 1 through 6, 1, 6, 2, 5, 3, 4. 1 through 4 for so it's 1, 4, 2, 3, and 1, 2, 4, 5. 1, 5 or 2, 4. Right? So with 2 or 4, we are guaranteed a duplicate missing digit, right? It's either 2 or 4 is duplicated here, right? It's either going to be 1, 4 or 2 or 3. um, I'm not sure what that tells us. Well, we know it can't be 3 duplicated twice. Oh, that's interesting. So if this is 3, 4 missing in this cage, you cannot have 2, 3 duplicated. Or so sorry, 2, 3 missing because you can only be missing 1, 3. Because otherwise it'd be 3, 3 here. This would not be 3 and 6. This would not be 3 and 6. This could not have a 6 anymore here, and no 6 here. So that's the reason why you can't have 3 missing twice. So if you have 3, 4, you cannot have 2, 3. That would be 1, 4 here. This could not have 3 4s missing, so this would be then 1, 5. So if you had 3, 4 missing here, oh, that's interesting. That forces this to be 1, 4 missing here, and then 1, 5 missing here. So you would not have a 2 in any of these. You would not have 6 in any of these. So what would that mean? This would again, this would not be 1, 3, not be 3, 4 here. So this would have to be 1, 2, 5, 6, 7, 8. You could not have 2, 3 missing here, so there's no 1, 4. No 1, 4, not 1, 7. So this would be 2, 3, 5, 6, 7, 8, 9. You'd have 4 missing twice, right? So 4 could not be any of these. 4 has to be here. Because you're missing 3, 4, you're missing 1, 4, you're missing 1, 5? 1, 5? So you'd be missing 1 twice, actually. So 1 could not be here, 1 could not be here, 1 has to be here, 1 has to be here. So 1 would be here, 1 would be here, 4 would have to be here, and 4 would be here, which would mean 1 could not be here, 1 would have to be here, so 1 could not be here. Therefore, 1 would have to be one of these, and this would never be 1. So since this is 1, this is 1, this is 1, none of these could be 1. None of these could be 1. This would then have to be a 1 here, which means 1 could not be here. So then 8 could not be any of these. So 8 would have to be here. 8 could not be here. This can't be 1 and 8 adding up together. So this is 3 and 6. 1 could not be any of these. So 1 would have to be here, which means 1 could not be here. 1 would have to be here. This would have to be 8 and 1, because that's the only possibilities left. This would be 8. Wait, okay, yeah, because we eliminated 8 there, because this can't be 1. 8 would have to be one of these 3, so it could not be here or here. 1 could not be any of these, therefore this would have to be a 1. This couldn't be 1 anymore. This couldn't be 1, so this would have to be 1 here. That would force 1 not to be here. This would be a 1-8 pair, so this would be 8, this would be 1. I mean, so far this all seems kosher. 8 could not be here. 8 would have to be one of these two, so this could not be 8. This could not be 8. This could not be 8. So 8 has to be one of these two digits, which means 8 cannot be here. We're missing 3 and 4 here. 3 has to be one of these. So it's 2 and 3 would have to add up to 5. So you could not have 2 and 5 here, no 2 and 5 here. Because 3 and 5 add up to 8, we can't have an 8 here. And then 3 and 4 doesn't add up there. So this is 2, no 2, 3, 5, no 2, 3, 5. That means this is 2 and 5 on the outside. 8 is one of these, so this can't be 8 here. 4 is one of these two, which means this can't be 4 or 5. 4 is one of these two, which means this can't be 4 or 5. This is 3, 6, 3, 6 pair. 4 is one of these two also, which means this can't be 4 or 5. 5 is one of these two. 5 has to be one of these. This is 4, no 1. It has what? 2, 2, 3, 5, 6, no 5, 6, 7, 8, 9. Obviously this can't be 3. Let's see. Oh, this has to be a 2, 7 pair, which means 2 and 7 can't be here. This must be 2, 7, and 9. This is 8. This can't be 1 or 2. This can't be 2. It's a 3, 5 pair here. 8 has to be one of these 3. This is 1. So far it's okay. 1 can't be here, 1 can't be here, so this is 1 here. So far this is looking fine. 4 cannot be here. Cannot be here. No 1 here, no 4 here, no 4 here. So 4 is one of those two. 5 cannot be here, therefore this is 3. But we have a contradiction. Where is the 5 in box 2? Can't be here because one of these is 4 and one of these is 4, so 5 is eliminated from both of these. 5 eliminates all there. 5 can't be an extra digit. So that's the contradiction with 3 and 4. So 3 and 4 cannot be the missing digit from box the 38 cage. Ugh, that was this. I know. So normally when I go down these paths is because I don't necessarily feel there's another way of determining this. But I feel there is for this one because I feel that there's a much cleaner way of doing this than the way I did it, I guess. Anyways, okay, so that rules out 3 and 4 as a possibility. Interesting. So actually, I think no, that was specific to those digits. Was it though? I don't know. So that was just if one is here and one is here, I think. Well, it was specifically if we had 3, 4, that requires a 1, 4 here, which requires a 1, 5 here. Right? Because then you'd have 2, 3, 4s if you don't have that. So that's specifically if it's 3, 4. But what if we assume this is 1 here and 1 here guaranteed? So therefore 1 is here, which means 1 cannot be here. Therefore 1 has to be one of these, so this can't be 1 here. 1 is one of these. 1 is one of these. So neither of these could be 1. 1 cannot be here. 1 is here, so this has to be a 1-8 pair. Well, since 1 and 8 are here, 1 has to be here. So since 1 is here, 1 can't be this. Yeah, that was only with 3 and 4. Okay, what are the other possibilities? If you have 1, 6 and 1, 5, that requires 2 and 3 here. So you can't have something like 1, 6, 1, 5, and 1, 4. You would have to have 1, 6. If you have 1, 6, and 1, 5, it's with 2 and 3. But what about 1, 6, 2, 4? Can you have... Okay, so the possibilities are 1, 6, 1, 5, 2, 3. 1, 6, 2, 4, and 1, not 1, 2, 1, 4. 1, 6, 2, 4, and 2, 3. I think those are all the 1, 6s possible. Yeah. Then you have 2, 5. 2, 5, 2, 4 requires 1, 4 here. 2, 5. 1 5 could go with 1 4, and 2 5, 1 5 could go with 2 3. Okay. The interesting ones is the restricting of the threes, right? Because we've shown that this cannot be missing 3 and 4 here, one of these has to be 3. So if we have another 3 missing, that would mean it would be either here or here. So if this is 3, this would then be 3, which means 3 and 6 would be missing here. And 3 and 6 would be missing here. Right? But this could be like 1, 2, 6. If this is like 2, 3, 4. Right. What does that mean? Well, 6 has to be one of these. So therefore, okay, so if there's a 3, it must have 1 6 as a pair, right? Because 3 would have to be in one of these. And so this could not be 3 6, and this could not be 3 6. So 6 can't be here, 6 can't be here. 6 has to be one of the excluded ones. Oh. And it also has to be inside. Ah. So there we go. This is why 3 cannot be either of these. So 3 cannot be excluded in any of the cages. Because if we have a 3, we tried excluding both 3s, right? And that failed miserably. If we tried to exclude one 3, the problem is that would mean the 3 has to be in this cage here then, right? So if 3 is excluded here, it has to be here, which means 3 has to be here also, which means 3 and 6 are both excluded on this zipper line because you need 3 added up with 6 to add up to the 9. So 6 has to be both in this cage, which forces this to be excluded 2 5, but then the only way you can exclude 6, and it would have to be in this cage, and it would have to be excluded, right? Because it has to be in one of these excluded digits here, and it has to be in the cage here because it can't be 3 and 6 here anymore. Therefore, if we excluded 3, we would have to include 1 6 in this 3 8 cage, but then that's the only cage that can exclude the 6 also, which means the excluded pair wouldn't be here, and it wouldn't be in the cage in one of them, and therefore we would not have a 6 either in row 4 or column 6 because of that. I hope that made sense, right? So we cannot exclude 3 at all. So it has to be then... Right, so we cannot exclude 3 at all, which means this can't be 3. This can't be 3. 3 has to be included in everything. This then has to be a 2, 3, 5, 6, 7, 8, and 9 cage. It cannot have 1 and 4. So we are excluding 1 and 4 in this cage. That means we're missing a 1 and 4. That means 1 out of 1 or 4 is excluded in this 39 cage, right? It's going to be either 1 5. So we're excluding 1 4. What else can we exclude? We have, if we have 1 6, it has to be 2 and 4 excluded with it. If it's 2 5, it could be either 1 5 or 2 4 excluded with it. That seems fine. Okay. So 3 or 4 is in one of these cages, and it's not 3 is not excluded in any of them. So that means the other 3 has to be one of these here, which means the 6 has to be one of those. So you have a similar one where 6 has to be here. Wait, hold up. Okay. Okay. So the possibilities are we know we have 1 4 required to be excluded from this 40 cage. It's either 1 6 and 2 4 because you can only have 2 excluded ones at most in these cages. Oops. So this would then be missing 1 6 here and 2 4 here. Right, so where are the 3s in row 4 and column 4? One of the 3s has to be within this cage, but one of the 3s has to be outside and therefore cannot be in the excluded categories. It has to be in one of the zipper lines, which means there must be a 6 in the other one. We know that the 6, though, is excluded in one of them. So if it's included in the cage here, it's included here, right? That means the 6 cannot be, it's either on the zipper line or it's in the excluded category. So this can never be 6. This can never be 6 before that reasoning. It's the same thing that the 8 and the 7 had, right? But we don't know. So either if the 6 is excluded, it has to be in one of these two cells, right? Because the 6 cannot be in both any of these. 6 can only be in one of the zipper lines because it can't be in the other one because the other one has a 3 in one of these cages. So since there's a 3 here, if there's a 3 here, that would force no 3 here. So 3 would have to be here, which means 6 would have to be here. So the excluded 6 so again, if 3 is here, there's no 3 here, there has to be a 3 here, that means 6 has to be here. 6 cannot be here. Therefore, 6 is either included, or if it's excluded, it has to be one of these two. So if it's excluded, it can never be here, or can't be here or here, right? Because if it's excluded, that means none of these can be 6. It has to be either here or here, right? Because either 3 is here, which forces not 3 here to be here, so 3 has to be here along this column, which means 6 can't be here, 6 can't be here. But there would also not be a 6 possible here, and it cannot be here because then 3 would have to be here, and that would eliminate that possibility. Therefore, the 6 would have to be there if that's the case. And therefore, the 6 could not be excluded here if that were the case. Or if 3 were here, you'd have the same logic, right? If 3 is here, 3 can't be here. Therefore, 6 can't be here. 6 can't be in the cage. Therefore, in row 4, where's the 6? It has to be one of these two, and therefore the excluded one is here, right? That's if we have an excluded 6. That's interesting. So what happens if we, again, have double excluded 1s? That's interesting. That means there's a 1 here, there's a 1 here. That means 1 cannot be here. 1 has to be here, which means this can't be 1 here. No 1 here. 1 has to be here, so 1 cannot be here. So since 1 can't be here, this can't be 8. 1 is either one of these or one of these. We double excluded 1. We're trying the 1/6 being excluded. There could be multiple ones though. So this would be 1, 2, 4, 6, 1, 2, 4, 6. 1 is here. 1 cannot be here. 1 cannot be here. This is a 1/8 pair here. We're excluding 1 and 6, so this has to be 2, 3, 4, 5, 7, 8. That means 1 does have to be here. So... that doesn't work. Okay, so we can't have 1 and 6 be excluded. Right? If we have 1 and 6 be excluded, if we have 1 and 6 excluded, 1 can't be here, 1 can't be here. That forces 1 to be here, because 1 can't be in here. But then this would have... Oh, I guess that's fine. No. Okay, that's fine. Never mind. That's okay. This would be 1, 3, 5, 6, 7, 8, 9. Right. That's fine. This 1 means this can't be 1 here. This is a 1/8 pair. 8 cannot be here. We're missing 1 and 6. So one of these needs to be a 6 here. It cannot be 6 here, because if this were 6, this would have to be 2 and 4 adding up. So it has to be 2 and 6 or 3 and 6. It therefore would have to be 2 and 6 adding up to 8. So we would not have 2 or 8 here. That's a 3, 4, 5, 7 triplet, which would force this to be 2. This would then be 8. 8 eliminates 8 here. So this is a 2, 7 pair, adding up to 9. This 2 eliminates 2 here, so this is 7. This is 7, that's 2. 2 can no longer be here. This can no longer be 7. 8 has to be here. So 8 is here, 1 is here. 1 cannot be here, or 2 cannot be here. 2 can't be here. We have a 3, 4, 5 triplet. This can't be 8. This can't be 2, 7. This can't be 2 or 7. This can't be 2 here, period. So the 2 has to be here, which makes this 2. This can't be 2 or 6 here. No 2, 6, or 8 in the rest of box 40. So this can't be 2. This is 6. This is 2. This can't be 2 here. This can't be 2 or 7 here. This is 3, 4, 5, 6, so this can't be 3, 4, 5, or 6. It's 4 or 6 here. Seven's one of these. 6 is here. One of these is a 1. Okay, this cannot be 1 then. And then we have a contradiction here. Okay. So we've shown that it can't be if it's 1, it can't be 1, 6 here. That's what I was trying to prove. Okay. What about... Oh, yeah. Okay. Well, okay, that's a contradiction. So it has to be 2 and 5 missing in this 38 cage. So we have 2 and 5, and we either have 1 and 5 or 2 and 4 as the missing digits in the 39 cage. So this is missing 2 and 5. So we have 1, 3, 4, 6, 7, 8 remaining digits in the 38 cage. Therefore, the 5 has to be either here or one of these 3 digits. I don't think it will be one of those 3 digits. Well, what if we're missing 5 and 5? That's interesting. So that means this is 1. 6 cannot be, actually, that's interesting. 6 cannot be here or here. We're missing either 1, 2, 5, 1, 2, 4, or 5. And either the 5 is doubled or the 4 is doubled, and the 1 is doubled or the 2 is doubled in the missing digits. We're not sure which. Okay, so either 2 is here or 5 is here, right? 2 and 5 are missing from these cells. Only one of 2 or 5 could be here. So either 2 or 5 is in this zipper line. So it could be 2, 3 adding up to 5. It cannot be 2 and anything else adding up to 6 anymore. It could be 2 and 5 adding up to 7, or 3 and 5 adding up to 8. So you cannot have a 6 here in the zipper line. You can't have a 7 here. So say it's 1, 4, 2, 5, and 1, 5 are missing. That means 5 cannot be any more along. It can't be in the missing. So 5 has to be one of these. So we're missing. So this is 2, 4, 6, 2, 3, 4, 6, 7, 8, 9. 3 obviously can't be either of these. 5 has to be one of these. That's 2, 5, 2, 3 added to 5. 3, 2, 5 adding to 7. 3, 5 adding to 8 is possibilities. 9 can't be here. We're trying 1, 4, 2, 5, and 1, 5 missing. So therefore this can't be 1. So this has to be a 1 here, which means this can't be 1 anymore. Which means this can't be 8. 1 has to be one of these 3, so it cannot be any of these. So this can no longer be 8 here. 1 is one of these because it can't be, it's excluded from the rest. So 5 is one of these. This is a 1, 8 pair here. 5 is excluded twice. 1 is one of these. The other must be 1 with 8. So 1 cannot be any of these. So this can't be 1. This can't be 1, which forces 1 to be here and here, right? But then we have a 5 in both of these, which means 4 and 5 cannot be here. 5 can't be anywhere here. Oh, 5 is fine in both of those. That's actually fine. Huh. Well, this can't be 4, 5 if that's the case. Oh. Well, that doesn't help much. No. I think that proves 4 and 5 can... Well, that doesn't prove anything, really. Huh. Hmm. Okay, that seems to actually work for 1, 2, 4, 1, 4, missing 1, 4, 2, 5, and 1, 5. Right? Um, yeah, the ones would have to be guaranteed here. Because one of these must contain a 1, and then the other one... Oh, okay, yeah, that's one thing. We have a 1 guaranteed here, right? So there's a 1 guaranteed in this 38 cage. There's a 1 guaranteed in one of these two zipper lines here for the 8. So that means 1 can never be either of these digits here. That's interesting. Um... So... Ah, bingo. And if you have two twos, well, no, one of them could be here. So either this is 1 and 1, because you have duplicate 1s that are not included in the cages. So you have 2 1s that are not included. Or one of these is 2, and the other one has to be a 2 here, right? Because one of these has to be a 2 to match the 7. So because one of these is a 2, you cannot have a 2 here and a 2 here. So this has to be either 1, 2 here. So if there's a 2 here, you could have a 4 or 5. That doesn't work as well. You can't restrict it as much then. Um... Huh. So the 1 is very restrictive, but we weren't leading to a contradiction. Hmm. Can this ever be 3, 5, and 8 is kind of a question, right? So if we have 3, 5, and 8... that would force this to be 2. You could not have 3 and 8 here. You would have to have 3 and 8 on the outside. No 3 or 8 here. This would have to be 2, 4. So we're missing 1, 2, 4, and 5. So this would have to be 1 and 1. So 1 could not be here or here. We had 3 and 8 missing here. 2 would go one of these, 2 would go one of these. This would be what? 2, 4, 2, 4, 5, 2, 3, 4, 5, 6, 7, 8. No 5. 2, 3, 4, 6, 7, 8, 9. Okay. So then 5 would be missing. 5 would have to be here and here, which means this could not be 4, 5. Okay, that's fine. So the 5 here eliminates 4 here and eliminates 4 here. One of these is 4, the other one's 2. That's fine. This would have to be a 1. So 1 could no longer be here. 1 would not be... would have to be one of these two. So this couldn't be 1. This couldn't be 1 here. So this couldn't be 8. So far this looks fine. 8 can't be here. This can't be 3. This can't be 3. This is a 1-8 pair here, which means this can't be 8. This is 3. This is 8. That eliminates 8 here. That 4, this is a 1, 2, 7 pair. 8 is eliminated here. Therefore, this is 8. This is 1. This can't be 1 anymore. 8 can't be here. 8 is here, which means 8 cannot be here. 8 is not here. So 8 is one of those two. 8 cannot be here. 4 has to be one of these. So this can't be 4 and 5 here. This can't be 2 and 7. It has to be 3, 8, and 9 with 6 here. So this is a 3, 6 pair. This 3 eliminates 3 here, so that's 6, which makes that 3. That seems fine. This can't be 6 anymore. One of them has to be 1, so this is 1 here. That seems okay. These can't be 3. It's a 2, 4, 5 triplet, which eliminates 2, 4, and 5 from the rest of the box. So this is 7, which makes this 2. None of these are 7. It's a 4, 6 pair, so this can't be 4. It's 2 and 5. This can't be 2, so it's 4 and 5. That makes this 7. So that seems fine. This can't be 7, and it can't be 4. It's a 6, 8, 9 triplet. This can't be 6. No, this can't be 2, so this is 5. This can't be 5. That's 2 and 4, which means this can't be 2, 4, or 6. It's 3, 5. This has to be a 1 remaining. And we have a contradiction because this is 1 and that's 1. Oh, okay. So we cannot have the 1 and the 1. Okay, right. That's, I think, the contradiction. Well, that was 3 and... that was 8. That was 8 there. Huh. I'm thinking it's something with this being 1. Right? If this is a 1, 1 and this is 1, right? This can't be 1, obviously. This can't be 1. This has to be a 1. So this has to have a 1 here, which means this can't be 1 here, so this must be a 1, 8 pair, so this can't be 1 or 8. Obviously, this can't be 1 here, this can't be 1 here. That means 1 cannot be here. 1 does have to be here if that's the case, which means 1 cannot be here, 1 can't be here, this must be 1, which forces this to be 8 to add up to 1 and 8. This can no longer have an 8 here, so this must be 8 here, which means 8 can't be here. This is 1, this is 8. Since 8 can't be here, 8 has to be one of these two. That's why you can never have 8 here. So 8's eliminated here. This has to be specifically 2, 7, and 9. So this cannot be 2 or 7 here. That 1, 3, 4, 5, 6 eliminates 1, 3, 4, 5, 6 in the rest of the cage. This is 2, 7. This is not 1. These can't be 1. Therefore, the 1 has to be here. This seems fine-ish. 8 cannot be here. So 8's one of these two, so 8 cannot be here. 2 has to be one of these two. So 2 cannot be here. So far that's fine, right? 1 has to also be here. This 2, 7, 9 eliminates 2, 7, and 9 in the rest of the cage. So it's 3, 5, 3, 5. Eight cannot be here. 8 can't be here. This seems fine, but we just showed that 8 can never be here. So that's fine. Right, because 3 and 5 would be here, 2 would be here, would be missing a 1, 5, so this would be 1 and 1. This seems fine. So this is either 2, 3 adding up to 5, or 2, 5 adding up to 7. Well, this can never be 3, because if that's 3, this is 2, and this would have to be 5, and that would eliminate that possibility. So 5 then, it's either 2, 3, and that's 5, or 2, 5, and that's 7. That seems okay. 8 cannot be here anymore, so 8 has to be one of these 3. 8 is one of these 3, that's fine. So 8's here. This is 1, this is 1, that seems fine. 8 cannot be here. It's fine. We know. Right, this is 1 missing from both. So this has to be 2, 4. Right, we're trying 1 missing from both, so it's 1, 4, 2, 5, and 1, 5 missing. So this is 2, 4, 6, 7, 8, and 9 with a 3. 3 obviously can't be here or here. So 5 has to be here and 5 has to be here, which means this can't be 4, 5. It's a 3, 6 pair, which eliminates 3 and 6 in the rest of the cage. Yeah, it seems fine. So 5 in box 2, in column 2 has to be one of these 2. So 5 cannot be here. So this must be 5, which makes this 2 and 7. This can no longer be 2. We have a 3, 4. Where's the 2 left here? It has to be here. This is 2, which makes this 7. So none of these could be 7. Therefore, this can't be 2. This is a 1, 4, 5 missing here. That eliminates 4 and 5 in the rest of this column. 7 can no longer be here, so this must be a 7 here. This can no longer be 7. This can't be 7. So far, this is okay. This can't be 2, 7, 8, or 9. So it matches this. 3, 4, 6. 2 cannot be here. One of these is 5. This 7 eliminates 7 here, so 7 has to be here, which means 7 cannot be here. So 7's one of these, which means 7 cannot be one of these 3. This can't be 8 because of that 8. This can't be 8 because of that 8. So far, this is all looking fine. 2 has to be one of these, so it cannot be here. Where is the 2 in row? This 5 eliminates 5 here, so this is 3, which makes this 5. So that makes this 4. This 3 eliminates 3 here, so it's 6 and 3. This can't be 4, and this can't be 6 then. So this can't be 4 here. It's a 2-5 pair, which eliminates 5 here. 5 can't be here. This can't be 3 or 4. This can't be 3, so this is 6, which means 6 cannot be here. This can't be 4 anymore. This can't be 6. 3, 4, 5, 8 eliminates 3, 4, and 8 here, so this is a 2-5 pair. This 5 eliminates 5 here, so that's 2. This is 5. This 3 and 6 eliminates 3 and 6 here, so it's 9. This can't be 3, 6, or 9, so this is 8, which works out 4. So this is all seems kosher right now. This can't be 9. This can't be 8. 3, 4, 6, 7, which eliminates 3, 4, and 6 from the rest of the cage. This is 2, 8, and 9, which eliminates 8 and 9 from the rest of that cage. This has to be 8. Can't be 8. This can't be 9. This has to be a 9 here. So this is all looking fine. This can't be 6. We have 3, 4, 7, 9 remaining here. Yeah, this is why I didn't want to go down this path. Because it looked pretty hairy. Can we do something else by trying other possibilities? Maybe. Okay. We know this can't be 8 here, so 5 has to be one of these 3, and 2 has to be one of these 2. Okay, that's good to know. What if we assume this is 4 or 6? Maybe that would be a good path to go down. If this is 4, that means 4 cannot be here. 4 has to be here, so it must be a 4-5 pair here. So 4 and 5 cannot be here. This must be essentially a 5, 8, 9 triplet, which means 5 and 8 cannot be in the rest of this cage. So this can't be 1 and 8. This can't be 1 and 8. This can't be 2 or 5 anymore because of the 2-7 pair too. That forces one of these to be 8, so this has to be 1 and 8, and there's no 1 or 4 or 8 remaining in that cage. So what does that mean? I'm not sure. We have a 2-4-5 triplet here and a 2-4-5 triplet here. Okay, well, there you go. That eliminates 2, 4, and 5 from the rest of that column and the rest of that row. So this would be 7 and 7, but that doesn't add up to 9. So that's a contradiction there. Okay, so that does tell us, so this cannot be 4. Therefore, 4 has to be here, which means this cannot be 4 and 5 added together, which means 5 has to be here, so 5 cannot be here, which means 5 has to be one of these 2 digits. That's probably where we get it. Okay, so since 5 has to be either here or here, this can never be 5. This has to be 7. This has to be then a 2-5 pair here. That means 7 can never be here. 7, 2, and 7 can never be here. So this is 1, 3, 4, 6, or 8 here. Because we have a 7 here. 7 can no longer be here. It cannot be here. So 7 is one of these two. We're not sure which. 5 is either here, which forces this not to be 5, which means 5 is there. Or 5 is here, which means 5 can't be here, 5 would be here. So 5 can never be here, and 5 can never be here. 5 can't be here for the same reasoning, and 5 can't be here for the same reasoning. Can this be 6 for the same reasoning, I'm thinking? Maybe, maybe not. Okay, if this is 6, that means this cannot be, this has to be a 3-6 pair here, which eliminates 3 and 6 from this cage. That eliminates 2 and 7 from this cage, so this is 3, 8, 9. This again cannot be 8, so this can't be 1 and 8. This is 2 and 7. 2 and 7 eliminates 2 and 3 here. This can't be 2 or 3. This is 1, 5, 1, 5. The 6 eliminates 3, 6 here. And we know we need to have a 1, 8 pair on the zipper line. So this is 1 and 8. This cannot be 1 or 6. This can't be 1 or 6 here. So what does that mean? That means here we're missing a 5. So 5 has to be here, and we're missing a 5 here. So 5 has to be here. Therefore, this is become a 1 and a 1 here. Which means this can't be 1, and this can't be 1. Okay, so that's a contradiction. So this would be 5 and 5 in the same cage, which is not allowed. So you can't have a 6 there either. Okay. Well, what does that mean? You can't have 4 and 6 both have to be here then. Because we've shown 4 cannot be here, 6 can't be here. They can't be here anyways because of 35 cage. It excludes 4 and 6. So this has to be 2 and 8. 4 and 6 both have to be here, which means this cannot be 4 and 6. This has to be a 2-7 pair, which eliminates 2 and 7 in the rest of the cage. That eliminates 1, 3, 4, 5, 6 in the rest of this box. So this is 2 or 8 here with a 7 here. This can't be 2 or 7 because of that. This is a 1-8 pair then. So that eliminates 1 and 8 from the rest of the cage. That makes this a 2-7-9 triplet, which eliminates 2, 7, 9 from the rest of that cage. So we have, this is 3 and 5. So this is 1 or 8, this is 1 or 8. And we're missing 2 here. This is 3 or 5, this is 3 or 5. So we know one of these has to be 8, and one of these has to be 8. So this cannot be, this 2-7-9 eliminates 2-7-9 in the rest of the box. So this is 8. This cannot be a 1-8 pair then. This can't be, 8 is here. So we're missing, this is 8, this is 7, this is 2 and 5. We know this is 3 or 5, and this is 3 or 5. 5 obviously has to be here, so there cannot be a 5 in the rest of the row or rest of the column here. 3 has to be here or here, which eliminates 3 in the rest of those rows and columns. So this can't be 3, and this can't be 3. I don't know what that tells us, but it tells us something. We're getting closer to solving this. I don't know how close, but uh, hmm. Okay. We still don't know what this is then that we're missing here. The one again seemed like it was kosher. So the one being here seemed like it was kosher. Um, I think I see it. So what happens if we're excluding both twos? If we're excluding both twos, either you cannot have a 2 being here and a 2 being here, right? Because that eliminates 2 in both of these spaces, and one of these has to be a 2. Actually, that seems okay. Hmm. Hmm. Oh, that's interesting. We know. Hmm. Either the 7's here, which forces the 2 to be one of these, or this is 2, which forces that to be a 7. But that doesn't tell us much, which would mean 7's here. Hmm. Yeah, that doesn't tell us much. Hmm. Do we continue on this later? It has been 2 hours, and I mean we're getting close. I feel, but we're still kind of not completely there yet. Hmm. Yeah, let's pause this for today, and we'll get back later. We're getting very close to solving this, but I don't know if my brain will work well enough for that to make sense. Anyways, I hope you enjoyed this aspect, and we'll continue on hopefully soon. And I'll see you next time. Take care.